Today we are going to learn tracing of the polar curves, curves in polar coordinate system. Now, first of all, we have to understand a simple polar coordinate system. Here, it is called as a pole, and horizontal line is called as the initial line. That gives the values of it is the position point and position line, or initial line and pole. If it is a point here, somewhere here, r theta is point, then angle described by that radius vector r with the initial line is called as a angle theta, polar angle, and r is the magnitude of that vector r, and therefore you can say that r is always positive, and theta will be from 0 to 2 pi. Now we'll discuss different points here. First point is point of the symmetry. Symmetry about the initial line. Symmetry about the initial line. If we replace theta by minus theta, and though equation remains unaltered, unchanged, then curve is called as symmetric about initial line. That is, curve is symmetric about initial line if that equation contains only cos theta or sec theta in the equation. For example, r is equal to a cos theta. A into bracket 1 plus cos theta is a symmetric about initial line. Here it is the initial line, here it is pole. Next point of symmetry is, if it is not so, try to find out whether a curve is symmetric about line perpendicular to initial line. And for that we require to replace theta by pi minus theta, so that it will be symmetric about vertical line, that is the line perpendicular to initial line, or in Cartesian coordinate we call that as a y-axis. The curve is symmetrical about line perpendicular to initial line if it contains sine theta or cosec theta, whatever it may be. R is equal to sine 3 theta. This is the figure of curve. R is equal to a sine of 3 theta. It is symmetric about the line perpendicular to initial line. Next symmetry is symmetry about the pole, this point. If that equation contains only even powers of r, r square, r raised to 4, r raised to 6, etc. Such curve is called as a symmetry about initial line. Now, how to find the tangent at pole? Tangent at pole is line joining tangent to the pole is given by substituting r is equal to 0. If you substitute r is equal to 0, we get values of theta. Theta is equal to pi by 4. Angle made with initial line. It is the radius. It is the vector passing through pole, and it is, if we write r is equal to 0 here, cos of 2 theta is equal to 0. Cos of 2 theta is equal to 0 means 2 theta is equal to plus or minus pi by 2 plus or minus 3 pi by 2, etc. In that way you can calculate, and therefore theta is equal to plus or minus pi by 4 plus or minus 3 pi by 4. These are the tangents at pole. Next, find out the limits where the curve occurs. How will find? Determine the numerically the greatest value of r, so that curve will lies in that circle. For example, here we know that maximum value of sine or cos theta is 1, and therefore r is equal to a is the maximum value of this curve, and hence the curve lies in the circle of radius a. Region. Determine the region in which no portion of the curve lies. Find these values of theta. How will you find? R square becomes negative for if it is greater than pi by 4, cos 2 theta is negative then. In second quadrant, cos theta is negative. For theta is equal to pi by 4, 2 theta is a pi by 2, cos pi by 2 is 0, and after that it becomes negative, and therefore in this part curve doesn't lies. Similarly, find out tangent at infinity. A tangent at infinity is occur in very rare cases here. If it is possible to write the equation in the form 1 by r equal to f of theta. That is r, if it is possible to write that equation in this form, then the asymptote of the curve is given by this formula. R is equal to sine theta minus alpha equal to 1 by f dash of alpha, where alpha is the root of the equation f of theta, root of the equation f of theta equal to 0, and f dash alpha is the derivative of f of alpha with respect to alpha. Here it is f of theta. 1 by r is equal to f of theta. If it is written in this form, then and then only it is for possible to find the asymptote. For example, the spiral r is equal to a by theta has asymptote as r sine theta. If here it is f of theta is equal to f dash theta is equal to 1, we get, means it is r sine theta minus alpha is equal to 1. You can calculate that to get the answer. Tangents at a point. Determine the points where the tangent coincides with the radius of vector of or perpendicular to it. I will find tangent. The angle between radius vector and the tangent at a point to the curve is denoted by phi, where tan phi is equal to r d theta by dr. With this help of calculators, you can find an angle between tangent and initial line is given by psi equal to phi plus theta. Right? Find out the table of values and draw the rough sketch of that curve. Next thing is, here are some examples. Cardioid. It is of this form. Cardioid is symmetric about initial line. For theta is equal to 0, you can get different values are there. And this is not my work. It is David R. Hill's work, etc. there, and therefore I am not going to give more demos here. There are different curves you can trace by substituting values of a. You can see that how it is works. Thank you.